So welcome to the next course in a series on architectures of artificial intelligence systems. Today I'm gonna talk about auto machine learning solutions. These solutions are extremely powerful nowadays, and what they essentially do are the most important steps in the machine learning model training and evaluation, like feature engineering, choosing the best possible machine learning algorithm for your problem, setting up the default hyperparameters, and tuning those hyperparameters according to your target quality measure, like accuracy or recall, whatever you choose. So at the end of the day, they may really help you to automate some activities which few years ago were extremely tedious and required a lot of almost scientific knowledge on machine learning modeling. So that's why I decided to focus on these systems as a separate lecture. I will compare PyCaret, AutoGluent, and AutoKeras, three out of many libraries of the type, as for February 2024. And when we look at the place of this lecture in our whole course, we are here. So it's in the fine-tuning section, and the section where we train and tune the model. So I hope it will provide you with some most interesting methods and tools which we'll be able to implement in your training practice. So let's start with the brief overview from the helicopter view. Where are we at the moment? So as I previously mentioned, we have experimentation and development stage and a production environment. Here we prepare the pipeline, which ingests some data, prepares data for modeling, and models the data. AutoML systems may help you here. Obviously, if you implement them in your pipeline as a code, because at the end of the day, as a code, it will also work here. So let's start with PyCaret. PyCaret, a very interesting library developed by the community. So let's dive directly into their website. What I like in PyCaret is that it's very well documented, quite intuitive, quite easy to try. You have a lot of different quick starts, demo, and documentation. So let's have a look at docs. A very powerful place for you are tutorials here. As you can see, you have separate tutorials for binary classification, multi-class classification, regression, time series forecasting, clustering, and anomaly detection. Dedicated set of tutorials for forecasting, so you can access them in Colab, interactive notebooks on Colab, in GitHub or Notebook Viewer. Moreover, you have very well documented modules. As you can see, you have dedicated modules for supervised machine learning, like classification and regression, unsupervised machine learning, like clustering or anomaly detection, or time series prediction. You have also dedicated section on datasets. So you have also data processing functions. As you can see, PyCaret may help you automate data prep, like missing values identification, data types management, one-hot encoding, ordinal encoding, etc. Scaling and transformation, normalization, feature transform, target transform, feature engineering of different type, feature interaction, polynomial features, group features, etc., feature selections, and other things. Moreover, you have very interesting functions which help you to initialize the project, train, optimize, analyze the results, and even deploy the model if you would like to create a toy deployment in the form of, for example, some Gradio app. You have a lot of blog videos, etc. If you look at the GitHub, let's have a look. So this is GitHub for PyCaret. As for February 2024, we have more than 8,000 stars here, as you can see, and updates are almost daily, so it looks like this library is live and being developed. Okay, that's about good points. There are some downsides, like problems with, that's my personal experience with putting this into production systems. If you wanna create something which completely does not require an interaction with the human, that may be a bit tedious with that. But still, I find this library a very good start, specifically for you if you would like to think about project for this course. I think it's a very good starting point, even if you do not plan to, if you do not have, do not plan to implement PyCaret in your workflow, then those tutorials may be a very good source of ideas for the projects for this course. So that's for PyCaret. We have also AutoGluon developed by Amazon. This is another very interesting auto machine learning library. That's my favorite choice for production. Why? Because maybe it does not look that nice like PyCaret, but it still has very good documentation and examples with tutorials. As you can see, it works perfectly with tabular data, but also multimodal, which is at the moment very, very hot, or time series. So for tabular models, as you can see, you have not only model training, but also feature engineering and some advanced topics like you can see multi-label, GPU training, etc. But in short, if you're interested in AutoGluon, this is the place where you can find tutorials, documentation, etc. But let me share with you my experience with that. The power of AutoGluon, in my personal opinion, lies in its parameterization, which is very important for production systems. So, for example, with one single parameter, I can ask the model to train, to fine-tune. I can ask AutoGluon to fine-tune my model in not longer than 10 minutes on my machine, for example, so that I can set it up that way. Or, for example, in one of my previous projects, I had to fine-tune the model for recall. It was binary classification model, and in order to fine-tune such models, you need to perform quite advanced feature engineering dedicated for just for recall, and AutoGluon did it perfectly. So there are some very advanced tweaks which make this solution very powerful for production systems. I didn't find them in PyCaret, so if you think about something production ready, I would definitely give it a try. So in one of my projects I completed a few months ago, the project after refactoring had 1222 lines of code. Very funny number, that's why I remember this. And thanks to AutoGluon, the model training, fine-tuning, evaluation, and inference stage had around 20 lines after more than 1200. So as you can see, you can easily simplify this model training and evaluation process using tools like this one. So that's open source still, so there is no need for payment, and I strongly encourage you to test it out. Okay, so this is the second one. A few years ago, it was also very popular to use AutoML systems for automated training of deep neural networks. One of the solutions of the type is AutoKeras, which you can find here. AutoKeras, this is the GitHub, but what I noticed now, it's Feb to February 2024. It's still quite popular, as you can see, 9.5 stars, but there is something with the updates. As you can see, it's not that highly updated. So once upon a time, I invested a lot in learning AutoKeras when I was developing deep neural networks. I think that it's still quite good technology, but in case you're looking for something in deep neural network area, I think it would be good also to look for something else. This is one of the most important aspects I look at, whether the library is developed or not. So these are those three my favorite libraries. Obviously, you'll find AutoML libraries. You'll find a lot of different comparisons of the type in the internet. My message to you is that firstly, be aware that there is something like AutoML on the market. There are a lot of very good open source libraries in Python which might help you to not only choose the best algorithm for you, but also fine-tune the hyperparameters and perform feature engineering. So at the end of the day, it may really simplify your machine learning pipeline, decreasing the complexity of the training and evaluation stage. So this is it for that part. Have fun. You will find some examples also in my folders. Good luck. Thank you.